Everyone, today we are going to explore lifecycle API in a Android platform. Basically, lifecycle API, it's a part of our Jetpack libraries, and you can read more if you are new. If you are working on an Android from like last 6 months, I'm sure you are aware of this API. In case it's new for you, you can go and jump into the developers.android.com and you can read. Mainly the benefit of this, uh, still I think you can read, otherwise I will take a lot of time only to explaining this. So we are what we are interested today. There are 2 3 points which can make you curious. So for me, like how under the hood they implemented, or we can say who is invoking these APIs. Invoke means like I implemented a small example. So I created my observer, which is a lifecycle observer, and then I'm adding this in a lifecycle. We will see later once we will jump in. And I'm adding this. So by adding this, what will happen every time when there is a on resume called, this will be called, and when there is a on pause called, this will be invoked. So we are also interested, uh, who is invoking this APIs under the hood. So yeah, I think we should jump in. So first thing, the one is this important part, lifecycle. What is this lifecycle object? As we are aware of this, basically it's a method name get lifecycle, and due to the Kotlin, it's showing us as a lifecycle. So in Java, this should be G get lifecycle main last intent, this one, and this one is saying, so I can go directly from here. So if I go there, we can see this is a component activity, and there is a kind of a surprise for me, and I'm like amazed. So when I'm aware of these activity hierarchy, so basically it starts from context wrapper, context theme wrapper, then it comes the component activity, then it used to be the fragment activity, then after some years they created some new app compact, then there is the app compact activity. And for me the amazing thing is, as we are moving, as Android is moving towards the composed UI, they are going back again to the component activity, which is, it's an old activity, it's there from long time ago. I remember this because, okay, for now only for testing I want to show you what I'm saying. So we used to do like app compact activity. This is the last version what I remember when I used to write code. And once I'm going inside of this, for now only try to make a graph or a hierarchy in your mind. So first is a my activity, which is extended from a app compact activity. So now app compact activity parent is a fragment activity, then fragment activity parent is a component activity. So as we are moving, and this component activity basically is same, which now we are directly using for the compose. So that is kind of a new thing for me. Okay, so one day once everyone will move on a compose, and it means these two activities will be gone. They can deprecate, they can obsolete, and we are not going to understand what are these, maybe some other video, but only I want to show you some code. So compose is not only the UI, like that is also giving the very, how to say, so it's giving a lot of power towards to the Android platform API. Like you can see these are all APIs will be gone. I have no idea what are these, but still this is a code. And so that is the one point which I'm amazed when I saw first time. So now we can go directly from main activity to the component activity. So in this case, we want to understand what is this life cycle. So basically it's saying life cycle registry. So it's again, it's an observer pattern. And in case of an observer pattern, the most easiest way to understand that, the API always check first the observer, because that is always a very simple API, and then coming back to the observable. In this case, the lifecycle is saving adding this, so it means that kind of an observable. So we can move first to the observer. So our observer is And again, it's a library code, Android Lifecycle. And this one is callback interface for listening to lifecycle owner state changes. So it's a default lifecycle observer which extends, and there are only these 6 methods: create, start, on, resume, on, pause, on, stop, and destroy, which extends from a, so this is an interface. These are all default methods. Default methods basically started in Java 8 if I'm not wrong. So, and then this is a direct interface, and then there is a lifecycle observer. So I think today I'm also thinking to make a hierarchy of or a graph, so understand how it's working. So this is the first part, and I will put here. Then I will say going inside of this is the second, which is extending. So here what we can do, we can say extension means, maybe we can make an arrow like this. So this means this full cycle observer extends from the uh, so default cycle observer extends full life cycle observer. So basically this is dependent on this. Arrow means like this. So that is our arrow, and then this is a observer direct. So this is the total hierarchy which we found until now for the observer. Now moving back, okay, so there are too many APIs who are implementing this full life cycle observer. Then who is implementing this? Android Compose View and My Observer is also doing this. But what we can do now, we can go back, and now we can jump into the get lifecycle. So what is lifecycle? We already saw. Defines an object that has an Android lifecycle. So this is an abstract class which is responsible for the Android lifecycle. And it's saying fragment and fragment activity classes implement lifecycle owner interface, which has the get lifecycle method to access the lifecycle. You can also implement lifecycle owner in your own class. So in any class where you are interested to make your class as an observable for the lifecycle, so you can make and implement a lifecycle owner, and these are the methods which they are calling. So yeah, just like we know in an observer pattern, there are always two APIs: add observer and remove observer, and then there should be something which is responsible to save all the observers. And it look like, okay, this is all our abstract method. We need to figure it out who is implementing this. And down from, so created on destroy, started on stop, resume, it look like the pair. So when the case is created, they are returning on destroy. Down from means return the lifecycle element that will be reported by lifecycle leaving the specified state to a lower state. And then this is a down to, so destroyed on destroyed created. And this is up from, okay, then this is a target state. Then these are the enum. It's a pretty simple class, there is nothing fancy. And now we have this abstract life cycle, but this abstract life cycle, so I think I should make a graph also for this. We will see how this one is working. So for now it's not clear, but we will see how they are matching with each other. Now coming back to this again, going here, now we can check what is this lifecycle registry, because this one is saying get lifecycle, but if I'm not wrong, this is override method. So there should be an interface, which one, which is lifecycle. So component activity should implement lifecycle owner, and lifecycle owner has a get lifecycle method. Okay, so there is also now lifecycle owner, that is a different API which is returning a get lifecycle. We will see. And how many, so there are too many classes which are implementing this, but currently we are inside of a component activity. So going back to here, so by implementing this lifecycle owner, now I have a method get lifecycle. So this is a lifecycle object, and this lifecycle object is an abstract. So I think it's a basically anyone who is implementing this, I think I can attach this with this, and then we will see, because it's kind of a composition, it's an interface. So anyone who is implementing this, that needs to return this get lifecycle object, and that it means that class should implement this lifecycle. So now going back where we are, so we started from here, lifecycle, and this is a registry. So this registry should be extend from the this class lifecycle. So now we'll see what is this. So it's saying it's an independent class. Going inside, yes, so we are right. So now this one is extends from the lifecycle. I think we can take this, so we can make our graph. So at this point, that is the part of our observer. That is currently we are looking for the observable implementation, and we will see this is the interface. This class is not the part of this. It's kind of in lifecycle, and then this lifecycle, basically this interface returns this lifecycle. So this arrow does not make sense here, and this extends from this. So we will see how to attach this. Okay, so what is this lifecycle? An implementation of lifecycle that can handle multiple observers. So this is our observable. So I will say this is our observable for these observers. And internally what they are doing, they have a custom list that keeps observers and can handle. So just like I shared with you, there should be a one array list or some kind of an data structure which save this. So they have this map which is saving lifecycle observer and the state. I think it's not the part of this video, but still we can check what is this fast safe iterable map. I never saw this. So Poor's man linked hash map which supports modification during iterations take more memory. That's so safe iterable map. It is not thread safe. Okay, so they are extending basically safe iterable map. What is safe iterable map? Linked list which pretends to be a map and supports modification during iteration. It is not thread safe. So if I'm not wrong, what does that mean? The modification during iteration, it means if there is someone is reading this and someone tried to remove that, that should not throw the concurrent modification exception. I'm not sure what does this mean, but as per my knowledge, yeah, if they are saying that supports during iteration, the modification during iteration, it means it will not throw the exception. Otherwise, you know, if you are doing some work and you are not taking care of a synchronization of the threads, there will be concurrent modification exception. So basically they extends this and they are only using internally. And this map, maybe we can see, so internally they are doing a composition with a hash map. Okay, this is confusing. That is also a entry, then how they are using double. Okay, hash map, then entry, and they are overriding this. So they are using this hash map, they are not delegating to this. Then put if absent, this is the method. Okay, then this is again they are using hash map. Remove contains and see. Okay, so mainly there are these methods. What other methods they have which they are not overriding? Remove, size, iterator. Okay, we can go back because otherwise we are in a different topic. So this is some kind of their own data structure which they made due to some reason. And then what else? State, current state. Okay, state means, I think so, if currently your screen is in front of a user, it means on resume state, if I'm not wrong, because their API is saying something like that. So these are the events and this is the state. Then they have a weak reference of a lifecycle owner. Then that is only one. Enforce main thread. Okay, we will see. And they are initializing. Then this is always true. So in component activity, they initialize with this. So this means this activity. And in that case, this activity, it means that should have lifecycle owner. So this is a lifecycle owner. Yes, this is a lifecycle owner. I hope now it makes sense. So this is a lifecycle owner, the component activity. What we can try, we can make this here. Then we can put this. So this one is a component activity, which is extending the lifecycle owner. So I can say this extends this. Then sorry about the arrows, and then if they confuse, then what else? Then this lifecycle owner has internally get lifecycle a lifecycle registry which they are returning on a get lifecycle method. So for now I'm putting this directly here. Because in the end it's returning. So this class has this lifecycle registry, and then this lifecycle registry, how it's working under the hood we already saw. This one is initialized first time. They are enforcing the main thread thingy, mark state, enforce main thread if needed, set current state, handle lifecycle event, move to state, is sync. Okay, there are too many. Okay, we are interested first in add observer. Just like when I call, for example, lifecycle.add observer, this one is calling this. This one is already implemented in a component activity, which is a lifecycle registry, and that is called. So in case of a component activity, I have this lifecycle. This lifecycle is taking from here this lifecycle, which is extended from a lifecycle registry, and it means once that is called, this is going inside. And after that, where is we are doing check. What is this? Ensure. Oh wow! So they are throwing the exception. I think we should confirm if we are on the right path. So it means if I do register this on not on the main thread, this should throw an exception. So what I will do, I will say thread start true, and then do this, and I hope this should crash. Okay, it's crashing. What is the reason? So it's saying method add observer must be called on a main thread, and what we saw in a lifecycle registry, the method add observer must be called. So yes, it's working. So that is new for me. So if you want to register, that should be always on a main thread. You are not allowed to register on a background thread. Then we are here, add observer. Where is the add observer? Then must this one is pass. They are playing with the states. I don't think so. We need to go inside of that. And then the lifecycle owner, get lifecycle owner, blah blah blah. They should save this information. Okay, adding observer, state, checking push parent state, and pop parent state, dispatch. So dispatching pop parent state, remove, otherwise state save. And in case of a remove, they remove from the observable map. If it contains, then go inside, but where they are adding in a observable map. So we are interested to found observable map dot put put. Okay, so once add observer is called, it's checking if it's not already saved. Save add observer with the stateful observer, and I think this contain the information at what state is it, the on create, on start. So until now this is done. At this point we are able to see add observer, and then the remove method also, remove observer. And also in case of a remove, you need to remove. So we conclusively decided not to send destruction events here in opposition to add. Reason for that, these events have not yet happened at all. So check your web connection, observer mat dot remove observer. Now we can check how it's notifying. So every time when there is a change, of event observer pattern needs to notify. In that case, there should be some kind of a notify method. Add observer backward pass, calculate, create unsafe, enforce forward pass, get observer count, is sync, mark state, move to state. So I don't know which method is basically okay, we can check again. Observable map dot something. Okay, where we are. Okay, the remove is done, size is done, there is an iterator. So once this iterator is running, is there any they are getting value anywhere they are push parent state? Is it okay? This one is the dispatch event. So here they are dispatching kind of a notify. And what this do, lifecycle observer on state change and lifecycle event observer internally have this. So is it implemented in component activity? Cool. So where we are currently, we saw these are the observers you need to implement, and these are the observables, like all information related to the observable. It's here in a lifecycle registry that is available inside of this component activity, which is saving these observers, and then in the end this one is notifying. Now what we can do, I think we can check how we know, like how OS API or a platform API figure it out it's a on create call or it's a on resume, because currently we only saw state change but we don't know who is calling this state change. Like for example, if we are calling this, who called this one is called by sync, this one handles only on top of stack, and who called this sync, there are two places, and who called this move to state is called two places. Then this one is a public method and this one is called from multiple places. Fragment activity, just like we saw in start. So because we are not using fragment activity in this case, we are using compose UI, so it's a component activity. And that, what is this fragment? So now we are checking in a fragment, so it means it's what type of fragment is this? Oh, okay, so it's a built-in fragment which we use for the UI, and that implements the lifecycle owner. Okay, nice. So just like we saw in a component activity, lifecycle owner implemented in the same way, Android internal fragment API is also implementing lifecycle owner, which means it should have the get lifecycle method, and which means get lifecycle is returning us the same kind of a lifecycle registry. Is there any lifecycle registry or anything, how they are understanding? So basically where we are, I'm repeating again, before that we check how things are working under activity. Now we are checking inside of a fragment, and our the last curiosity is still there, who is informing to these APIs, like okay, now on create is start, on start, on resume is called. So that one we will jump in after this. So and also okay, so they have a different fragment view lifecycle owner which has this implementation, which is implementing from a factory. Okay, and inside of this there is a get lifecycle initialize registry. And what is this? Oh, okay, so the registry is same which we saw in an activity, they are using the same in a fragment, but that is implemented or available under the hood of this lifecycle owner class. View model store, then they are initializing here. Nice. And where they are doing, so in this case I have an access in a fragment, and if I try to access this, where is this lifecycle owner? Okay, we can play to crash here, but I'm saving some time, so I'm not going to implement this. Then there we are doing what, handle lifecycle event on create, restore view state, new fragment view. So they are making here, once the view is run, so on create, perform create view, most probably that will be called somehow under the hood on create view, and then this one is called, then after that on create view is called, then is initializing, then after doing they are also using live data. Nice. Then what else? Okay, so at this point they are also saving information in a registry. It's on start, and they are also giving this information to the lifecycle owner separately. So they have separate lifecycle owner and then separate registry, and then this lifecycle owner also have inside of a lifecycle registry. This is confusing. So what I'm saying, they have a registry inside of a fragment, then they have a fragment view lifecycle owner which also have their own registry. And what is the difference then when this one is used and when this one is used? So we can check. And everywhere, like in this case they are calling on create, here they are registering add observer state change. Oh, nice. So basically once we create a fragment under the hood, they are adding an observer at a fragment level API, like, and from then they are taking care of the notification, like once the state change, this event is getting this some information, and if it's this, then they are checking if view is not null, then they are doing some stuff. Event on resume, they again handle lifecycle event, plus they are also sending this on resume to the lifecycle owner. So lifecycle event under the hood move the move state. When this move state is happening, it's syncing. Then okay, so basically in fragment we found when there is a on resume or anything change, they don't implement the as per my understanding, OS did not implement it separately. Basically they are using fragment internally. So this fragment is the one who is informing the observable, hey, there is a state change. So from here, once this one is sent, then, so for example, assume in a main activity my own resume is called, basically who invoked this. So I'm going, so under the hood they have this component activity, and in case I implemented the fragment, then I think this will be this is going to be used. But in this case, how they are implementing that is we need to figure it out. So in case of a fragment, like for example, I have an activity A which contain a fragment A and fragment B, and then fragment A is registered this. In that case, when there is a change anywhere, this method will automatically invoke, and then this one is going inside of here, and this one is saying, okay, move to state. Once the moving state is done, they are saying do sync. And once the sync is start happening, they are calling forward pass or backward pass, it depends how, and then inside of this will invoke the observer, the dispatch, and this dispatch will invoke this. I hope you are able to understand. It's not confusing, but yeah, theoretically it's tough. So this one is calling from here if I implemented the fragment. But now the next question, my curiosity is how the component activity is called this, because that currently I don't have a fragment, so still I am getting. In that case, to save some time, what I can do, I can use now the debugger, because today I don't think so we are using anything at a C level or any AIDL API. So hopefully debugger is able to give us the exact location. So started debugging, and once it's going to be on pause, so still not called, now should call. Okay, so now on pause is called. Now we will see who invoked this in on pause. So on pause is coming from the on state changed, and this is a new class which we found. Its name is full lifecycle observer adopter. So they have an adopter inside of a library which is implementing lifecycle event observer, which we already saw before. So in this case, this on state change is invoked, and at this point it's sending this information, and then that is invoking this now. But we will go one more up level, who is calling this method dispatch event. And this dispatch event is a lifecycle registry which we review 5 minutes ago. So like this one. Okay, now we can connect all these dots. So lifecycle registry, and we already registered here, and this one is saying okay, dispatch event is called. Now who is calling this? And this is a backward pass. Backward pass means because I think we are already the activity is already in front of a user, and on resume is called. So once I click, basically it's calling on pause, and on pause is going, I think so, backward. So I think backward means pause, on stop, on destroy, and forward pass means on create, on start, on resume. Again, maybe I'm wrong, but that is my understanding now. And then who is invoking this backward pass? So this is a sync method. We already saw sync, and this sync is calling move to state. Oh, nice. So we are aware of this method. Handle lifecycle event. This one we already saw in a fragment case. Fragment is responsible to call this, but in this case, oh, report fragment. What is report fragment? Because in my case, I have a main activity which has no fragment, which is only extending from the component activity, and component activity has no fragment. It's an activity. So this is interesting. Report fragment. So what is report fragment? Who implemented this? Internal class that dispatches initialization events. Nice. Dispatches initialization events. What this do? So inject if you need it, and then lifecycle register in if the API is 29 plus. Otherwise, fragment manager, get fragment manager, find fragment if not available, create a new fragment. Oh wow. And then okay. So okay, so my understanding is once we have a component activity, and as a client or as a developer, I am not going to create any new fragment. But how this lifecycle API is implemented, basically under the hood, the OS or this, sorry, not OS, the platform and the library, Jetpack LifeCycle library API internally implemented a one report fragment. Okay, and they injected that under the hood inside of a, we will see how. And then this report fragment is, because fragment is there from last 8 years, if I'm not wrong, in 2013 they added, and fragment is already aware of the lifecycle events, like we know on create view, on activity created. So what they are doing, they are reusing that. Only they added a one abstraction, lifecycle API, lifecycle owner, lifecycle observer, and they are saying okay, report fragment we will initialize under the hood, no one knows. And then when this on fragment change, any event is changed, they are pushing events from inside of this report fragment. So basically what I'm saying, like, yeah, like you can check this one. Oh, nice. So basically once this fragments on start is called, what they do, they are calling dispatch start and dispatch this event. And these two methods, what they are doing, okay, if the listener is already initialized, then call this on start. And in case of an event, again, both are basically process listener. This is an API, and this one is a lifecycle API. Oh wow. So in simple words, internally they have a one fragment who is responsible to invoke this lifecycle methods. And once the OS APIs, how the stack is working, when the fragment is invoked, these APIs, they have the API implementation, the listeners, they are pushing, calling that listeners, which are later calling these lifecycle observer API, and how they implement it. That is amazing. So then dispatch event, and these dispatch events we can again, you can see how they are implemented. So once the fragment on stop call, they are dispatching that. Then they also have static lifecycle callback for API 29, I think so, above. In that case, what they are doing, they are sending these events in a different way. So they are saying okay, when this one is called, dispatch this event. Beautiful. Then behind the scene, again, now it's an activity. So in this case, what is this method? Dispatch activity pre-post application activity lifecycle on activity pre-post. Okay, application activity lifecycle callback. If I'm not wrong, we are also able to register lifecycle callbacks of an activity with the application, and under the hood they implement it for their own self, and then that is called, as per my hunch, then perform pose. Once the pose is called, and this is a activity class still, and then after that I think this one is the, we already aware of these info when we test when we work on a zygote video. We are aware of all this code. So coming back to this, so I'm really interested to explore more this report fragment. So until now, I'm summarizing again. Main activity, once we are implementing the lifecycle observer, basically component activity, there is a component activity under the hood, which has this registry and they are saving. Now, how they notify there is a lifecycle change, they have a report fragment for who is responsible to inform or dispatch this information. Now, the last thing I think we can jump in to figure it out how they are injecting this report fragment internally inside of an activity. I hope we will find. So this is a one method which is a static method, and this is responsible for this. So we can see it's taking the activity fragment manager. So this one is pushing. So, and this one is called in two places, but it's component activity. So 354. Awesome. Okay. Nice. So component activity have internally injecting this report fragment, which we are not aware of as a developer. Like I'm not aware of in main activity, I'm using any fragment, but there is a fragment under the hood. And this one is responsible to take care of the lifecycle events. And what about the other place? What is that? Is 87. So, so this one is restricted API on create, and they register this. Once this is done, the fragment is ready, and then this fragment is sending us the events. But what about the on create event? So this one is on start, on activity created. Okay, wow, nice. So on activity created is a fragment method, and once this is invoked by the, so our activity is this, which is extended from the component activity. So once on create is done, under the hood component activity already injected report fragment. So once this is called, on activity created is done, they are calling internally, APIs are calling on activity created of a report fragment, which dispatch this event. Okay, now on create dispatch, do the dispatch for the on create, do dispatch for on start. It looks pretty nice. So if I try to make a graph, basically what is happening, uh, what they do. So can I draw here? Okay, so I can try. So basically this is a component activity, and we have our main activity, which is, sorry for the drawing, extended from this. Then this one internally has a report fragment, and the remaining lifecycle owner, observer, that is already implemented registry just like this. And once the report fragment on create, because this one is injected into this component activity, and once the remote fragment on create or on start called, that will invoke, that will dispatch the lifecycle observer API, this lifecycle registry if I'm not wrong, and then that will go inside of that will sync, and then that will notify, okay, back pass or forward pass, and then that will returning, and event is coming until at this point. So then this one got, that is pretty nice. So I hope we learned something new today. See you in our next video. Bye.